Write down the expansion of 1 plus x to the power of 6 in ascending powers of x up to and including the term in x cubed. So binomial expansion, the form of this that we wish to use is 1 plus x to the n equals 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 all over 3 factorial x cubed plus dot 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 dot. Now in practice, although this is the form of the expansion that we're looking to use in this example, it's far easier to remember this as patterns. So I get 1 plus n, which is 6x, plus, count down from 6 times 5, only 2 terms because it's x squared, and on the bottom 1 times 2, counting up, so that I have the same number of integers top and bottom, top counting down, bottom counting up, times x squared. Plus, counting down, x cubed means I've got 3 terms, 6 times 5 times 4. The denominator has got to have the same amount of terms counting up from 1, so 1 times 2 times 3, x cubed. Okay, now simplifying my terms, I get 1 plus 6x. I can cancel the 2 with the 6 to get 3 times 5, which is 15x squared. And then on the bottom I can cancel 2 times 3 is 6. So 5 times 4 is plus 20x cubed plus dot 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 dot. Okay, so how are we awarded marks in this question? Well, you are given full 2 marks if you get to this point, standalone marks if the whole thing is correct. You can have 1 mark if you manage to get 3 out of the 4 correct. Part B, so that was part A. Part B says by substituting an appropriate value for x into the expansion for A, find an approximate value for 0.99 to the power of 6. We've got to show all the work in and give an answer correct to 4 decimal places. Now, what we're suggesting is that 0.99 to the power of 6 is equal to 1 plus x to the power of 6. Now what that is suggesting then in that case is 0.99 is equal to 1 plus x. So if I subtract 1 from both sides, we get the appropriate substitution that x should be 0.01. And that should be, let's make that clear, negative 0.01, not positive 0.01. Okay then. Now let's substitute this into the expansion so I can get a value. Now we're going to move on to the next slide just so I've got a little bit of space. So we said that x is going to be minus 0.01. The expansion 1 plus x to the power of 6 was 1 plus 6x plus 15x squared plus 20x cubed. And that's all we're using to do our approximation. So I'm going to drop the plus dot 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 dot. So what we get is that 0.99 to the 6 can be approximated by 1 plus 6 lots of minus 0.01 plus 15 lots of minus 0.01 squared plus 20 lots of minus 0.01 cubed. Now this might appear fairly challenging to do, but you should be able to do fairly straightforward decimal multiplication without a calculator. 6 times minus 0.01 gives you minus 0.06. Plus, do this in stages. Minus times a minus will give us a positive, so I can just give a positive answer here. 0.01 times 0.01. 1 times 1 is 1, and then there's 2 decimal places in 2 numbers after decimal place. So I'm going to get 0.0001 plus 20 times a negative number cubed will be minus, and then 0.01 times 0.01 times 0.01 means I'm going to get 1 times 1 times 1, which is 1, but in 6 decimal places. 5, 6. Okay, so we're almost there. I'm not going to do, well, I could do that subtraction at the beginning, so 0.94 plus 0.0015, and then 20 times this gives us minus 0.00002. Now, easiest way to carry out this subtraction will be just to simply take 0.94 and plus the 0.115. So that bit's easy. 0.94 plus 0.15 will give me 0.9415, and I'm just going to subtract 0.00002 from that. So put in a 0 at the top. Now 0 take away 2 I can't do, so I'm going to borrow 1. I'll pay back down the bottom so that I get 10 take away 2, which is 8, 5 take away 1, which is 4, 1 take away nothing is 1, 4 take away nothing is 4, 9 take away nothing is 9, and then 0 take away nothing is 0, which then gives us the approximation. And we have to make sure that we do the approximation fully, because it might not always round nicely like it does here, but 0.9415 corrects to 4 decimal places. Okay, well, how we are awarded marks in this question? Well, first of all, we're going to get a method mark if you find this x equals 0.01 and then there's some attempt to substitute this into your expression. So method mark for substituting it into the expression. Okay, you then get an accuracy mark in the expression if you get 3 out of those 4 terms correct. And then finally you get your final accuracy or answer mark for this answer down the bottom if and only if you get this correct answer to 4 decimal places.